when two waves of same frequency, nearly same amplitude and constant initial phase difference travel in the same direction along the same straight line, they superpose in such a way that the region of superposition, the intensity is maximum. Means what? Intensity is maximum.
Brightness.
It is bright spot. So the intensity is maximum at some points and minimum at some points. That's what is happening. Maximum, minimum. Sorry. I cannot write it. Minimum. Okay. So if this kind of a phenomenon happens, that is what we call it as interference. Now the question is, for this interference to take place, one thing is clear, that it is happening because of the superposition of waves. That point is clear. But what kind of waves are supposed to be used for the superposition so that you observe a clear pattern of it? The first few statements tell you that you need to have two waves of same frequency, nearly same amplitude, and constant initial phase difference. Is it clear? So, if at all you have two sources which follow all these conditions, those kind of sources are called as coherent sources. It's a very, very, very important point. Please make a note of it. Please make. Okay. So the sources having the same frequency and constant initial phase difference are called as coherent sources. And the phenomenon of interference is based on the law of conservation of energy. Maybe this can be a one-mark question. It is based on the law of conservation of energy because the intensity of the light is redistributed. It is not lost. It is redistributed, meaning initially, let's say this light had intensity I1, this light also had intensity I1. So I1 plus I1 is going to give you 2I1. So there are two operations that are possible mathematically. You can add them or subtract them. When you subtract, it is going to be 0. So if the intensity is going to get added, you are going to get a spot like this. If the intensity is going to get subtracted, you will get a spot. You will get a dark spot. Okay. But here, if you observe what is so, in a complete bright and the dark spot, how much is the total intensity that is there?
2i.
It is still 2i only. Initially, before this pattern, what was there? It is still 2i. So you're able to understand the energy is not lost. Rather, what is happening? Redistribution is taking place. Okay, that is why we also say this is another way of defining it. This modification in intensity in the region of superposition is called interference. Okay, if somebody asks you what is the definition of interference, what exactly is happening? The thing that you're able to observe is the modification of intensity in the region of superposition. Okay, and some books refer to it as redistribution of intensity. Both are same. Clear, guys? Okay, and one more important point. Can you people answer? So for interference to be observed, what kind of sources are supposed to be used?
Monochromatic.
Monochromatic.
Monochromatic is there. Okay, monochromatic is there. Then I told you one more important point. They should be coherent in nature. Okay, going forward, I'll not use this word again and again, but you need to understand that whenever we are discussing, it is actually about the coherent sources. Okay, so what are coherent sources? Frequency and constant initial phase difference is taking place. Okay, so after this, the concept that we need to know is what is this sustained interference? Sustained means what? Sustain is something is lasting for some amount of time. Okay, if something is lasting for some amount of time, we call it as sustained interference. Are you guys able to understand?
Yes, sir.
So that's what is given. See, the interference pattern in which the positions of the maxima and minima remain fixed is called sustained interference. The meaning of it is, imagine you're doing this experiment, okay, with the same green light. We can call it as a sustained interference if you're able to see the green light here, even when you come after 10 minutes and see it. If you have located a green spot on a particular position of the screen, even if you come after some time, If it is at the same spot, we call it as sustained interference. If it is swapping, like say it is vibrating between these two spots, then it is not called as a sustained interference. So speaking, why we need a sustained interference is because we have certain things to be studied, right? Our interest of study is to find out what is the difference between two bright spots that are happening. What is the difference between, or what is the position difference between two subsequent dark spot? Or I would be interested to know what is the difference between the first dark spot and the fourth dark spot, right? If I have to do all these distances, let's say you take a scale and measure, you can measure these values only when there is a fixed quantity on the screen, right? Something should be fixed. If it is moving, you will not know where to keep the zero of the screen. So that is why we need a sustained interference. Okay. So there are certain conditions for sustained interference case. So what are they? The fundamental condition for sustained interference is that the two sources should be coherent in nature. That is, the initial phase difference between the two interfering waves must remain constant with respect to time. They should not change with respect to time. Second, if you need a better quality, then you need to choose the waves in such a way that the amplitudes of the two waves should be equal or nearly equal. They should not have a very great difference. Okay, it is advisable to take equal amplitude, but sometimes when it is not possible, you can take two sources of nearly equal amplitude. Okay, so this will give good condition or good contrast between bright and dark fringes. So what do you mean by good contrast is, here you're able to differentiate the colors, right? Sometimes what will happen is, if suppose I'm using red light and I have a pattern like this, okay, so red light means there's going to be the bright spot. So what is the difference between the diagram I drew and the one which is already there?
White spot is larger area than the dark.
They're almost overlapping, right? You're
Yes,
able
sir.
to see. So in the diagram which is given here, there is sufficient. So there is some breathing space that is there. Whereas the one which I drew, it is like the bright and the dark spots are almost overlapping with each other. So sometimes what will happen is, you might have a condition like this also. You're able to see. Actually, there is a dark spot. If I zoom, I'm able to see. But if I zoom out, I'm not able to see. I'm zooming out. It will not be that clear. Okay, the clarity is missing, right? So if these clarities are required, what should happen? For this clarity to be obtained only, they are saying that you take both the waves to have nearly same amplitudes. Okay. Next. The next important thing is, the two sources should be very closely spaced. Sorry.
Sir, I have a doubt.
Yeah, tell me.
Sir,
Your voice is breaking.
does the bright spot have a color?
Yes, it does.
Am I audible, sir?
Yeah, it is. Yeah, you're audible.
Does the
Yes,
bright spot have a color?
yes, it does, because you're using a light of a particular wavelength. No, that wavelength is going and falling on the screen. If you use red color, you will have a red color spot. If you use
But
if
that
you use
red
green, you're
light
going to
should
have.
be a coherent source.
Yes, I will come to that point. You cannot have two red lights. See, suppose I give you two laser lights, okay? To our eyes, how will it appear? That both will emit the same red color, right? If I give you two laser lights in your hand, let's say that laser light is emitting red color. Okay. To our eyes, how will it appear actually? They will appear to be red color. So what we think is, they both are coherent sources. But the same color also, if you use different materials, they are not coherent. That is the reason why I was about to tell that point, but you asked. So I'm telling you. So that is the reason why we used a single source and we tried to split the single source into two sources by using two holes. That is the reason why we are using, because no two different sources are going to be coherent in nature. So for coherence to get generated, you need a single source. Okay. So as time progresses, you will understand, because those points will come. Okay, so the two sources should be very closely spaced in the sense here. See, I'm erasing everything. Please observe, guys. Since you have understood this, here, though we have only one source, why are we saying two sources? Because of two openings. We have actually broken it into two parts, right? This slit and this slit should be made in such a way that they are very close to each other. Very close to each other in the sense the distance small d between them should be very small compared to the distance between the slit and the screen. Okay, that is a very, very important condition. D should be very much less than capital D. Are you guys able to understand this point? That is the third point. So two sources should be very closely spaced. Otherwise, the fringes will be too close for the eyes to resolve. This is the meaning. The other day I told you what is the meaning of resolution, right? Looking at two different things as a completely different entity. They should not be overlapping on each other. That is what is called as resolving. Fourth one, the sources should be monochromatic. I told this to you, right? So it should be monochromatic. Otherwise, there will be overlapping of interference patterns due to the different wavelengths, which will reduce the contrast. If you use white light, no, you will have 7 colors that are coming out of it. Kritika, you asked the question, right? So if you use a white light, no, what?
Yes, sir.
By the way, yeah, you only asked, right?
Yes, sir.
So if you use a white light, no, what will happen is you will be able to see all the 7 colors on the screen. That will happen. Okay. So that is the reason why we are using a monochromatic. Next, the frequencies of the two interfering waves must be equal. This is a very, very important point. And the last point is the sources should be narrow. Now comes the important point, guys. Listen, since two independent sources cannot be coherent, when I say two independent sources, even two lights, okay, if I have two torch lights in my hand which are producing the same green color, though the color is the same, we can say monochromatic because it's green color. But these two sources taken together will not be coherent. That is happening because what is the main reason for electromagnetic wave to get generated? Again, we'll go back to the basic. I've told this already. What is the source of an electromagnetic wave?
An accelerating
Oscillating.
particle.
Accelerating charge particles.
Accelerating charge particle means the source in this need not produce the same way it is producing the other light. Because for them to be coherent, what are all the conditions to be satisfied? Maybe you can generate the same frequency, but you will fail in the process of generating the constant phase difference. That is the reason why no two independent sources are going to be coherent in nature. This is a very, very important point. Now, I hope you would have understood why we are actually breaking the same source into two different by using a single source and two different slits. Am I clear till this point? If you're clear till this, other things I can take it easily. These are all very important. Is there any doubt in this?
No, sir.
Sir, what is
All right.
fringes, sir?
Fringes means this one. This is a fringe. This is a fringe. We can call it as a bright fringe and a dark fringe. So I use the word spot, no? Instead of saying spot, we
Yes,
call it
sir.
as fringe. That's it.
Okay,
The
sir.
different synonyms, and that's it. Okay. So shall I proceed, guys? So this is all about the theoretical part and the visualization of what exactly is happening.